Before we go on to the next example, I want to introduce some terminologies that are used specifically for the trigonometric functions that are transformations of sine of t and cosine of t. Specifically, let's work with this one here. So minus 3 cosine 1/2 t plus pi over 2. Now, these terminologies, these definitions that I'm about to make, are much easier to recognize when we write it in the form where the 1/2 is factored out of both here and here. So I'm going to do that now. Minus 3 cosine 1/2 t plus pi. So when you write it of this form, then the vertical stretch / shrink is called the amplitude. So it's called the amplitude. And so in this case, the amplitude is going to be 3. You do not include the negative when you talk about the amplitude. So the amplitude for this particular graph is equal to 3. And what the amplitude represents graphically, if we go back, is it's going to be this distance between the midline and the upper and lower lines. And indeed, you can see that the amplitude is 3 because the y values up here are 3 and the y value at the midline is 0. So the distance between 0 and 3 is in fact 3. So that's one particular naming convention that we have in the context of transformations of sine of t and cosine of t. Another definition that we have is one that we already introduced, and that's called the midline. So the midline, that will occur at y equals the vertical shift. Now, in this problem and the previous problem, the vertical shift is 0. And so the midline is y equals 0. And if you think about it for a moment, that makes sense. We can go back and revisit our computation of the midline, which was right here. If there was a shift where we added, let's say 5, then 0 times 3 plus 5 would be equal to 5, and it would give us a midline of 5. But there's not, and the midline was 0. We'll see in the next problem that the midline will occur at this vertical shift, which would be plus 1. So those are two important definitions regarding the relationship between the vertical transformations and the naming conventions that we use with the trigonometric functions. There's also some definitions that we use for the horizontal transformations, one that we have already introduced and another one which we have not. So let's go ahead and maintain this equation on the page as we introduce our other definitions. So the phase shift of a transformation is simply the horizontal shift. But it's the horizontal shift when we have this form here, that is when we list the shift last. And it has the convention that if it's a left shift, we put a negative. So in this case, the phase shift is minus pi. Okay, it's not minus pi over 2. We don't look at this form to get the phase shift. You always have to factor out whatever number is multiplying t, or in other problems perhaps x. And then finally, the piece of terminology that we know is called, or that we've heard before, is called the period. And that can be found two different ways. So the period is, you could do the difference between the very last t-coordinate and the first t-coordinate. So the first way is, let's look back to this. The last t-coordinate is 3 pi. The first t-coordinate is minus pi. So 3 pi, that's the last. Then you have to subtract the first, so minus negative pi, and you get 4 pi. But this way is a little bit challenging because it's hard to determine, well, you've seen that it takes some work to figure out the first and last coordinates just by looking at this equation here. You can actually find the period a little bit easier using the second way, which I needed a little bit of more room for, so I made a new page. And that is, you take the old period, that is, maybe I could phrase this a little bit better, the period of the parent function, and you divide it by whatever number is multiplying right here. So this is 1/2, so we'll divide by 1/2. And now the period of the parent function was cosine of t. And the period of cosine of t is 2 pi. In fact, in this section, when we're talking about sine of t and cosine of t, the period of the parent will always be 2 pi. But you'll see later that there are some trigonometric functions which do not have period 2 pi. So that's why I put the period of the parent, so that you can remember this may change based on what trigonometric function you're working on. However, in this section, it will not change. Only in later sections will it change. And the period of the parent is 2 pi, and we're going to divide by 1/2. And that gives us a period of 4 pi. So there's two different ways. One way in which you can find if you have the first and last important t-coordinates, and the second way for which you do not need those first and last important t-coordinates. And all of these definitions are very frequently used when talking about the context of transformations of trigonometric functions. Phase shift, period, amplitude, and midline.